Hello, this is the day one of the pre-algebra prep summer class, and I just want to go over in a brief video the things that we covered in day one of class. And we're going to be talking a lot about exponents and what to do with different exponents, especially as we start to join them together. But in order to do that, we need to understand a little bit more about exponents and why they work, and we need to understand, first of all, that God has created everything decently and in order, and we are just really discovering what God has already put into place. And one of those things that we discover, especially with math, is that there's a lot of things that are patterns, and if we follow those patterns, we start to logically make sense out of some things. So what I have up here to kind of get us going is basically, if I have a number such as 3, and we could use any number, we don't have to use 3, but we are going to today just for sake of example, and I say that 3 to the 5th power, most of you would agree that 3 to the 5th power is really 3 times 3 times 3 times 3 times 3. And if I was to multiply all those through, I would end up with the number 243. Thus, 3 to the 5th power is the same as 243. Well, if I go down and just follow my normal pattern and decrease by a 3, which now means 3 to the 4th, now I have 3 times 3 times 3 times 3, which equals 81. And if I continue to follow the same pattern, 3 times 3 times 3 is equal to 27. Well, as I can see that I'm dropping a 3 each time, what I'm really doing is going from this number down to this number. I'm also doing an operation. The operation that's going on here is I'm dividing by 3. So in order to get to 243 down to 81, I would divide 243 by 3. Following the same pattern, if I divide 81 by 3, I would end up with 27. And we can continue on with this pattern, and it just makes logical sense that now if I divide 27 divided by 3, it equals 9. And if I divide 9 by 3, I end up with 3 again. And so if we continue to follow this pattern down, we're going to start to discover something. And one of the first things we discover is the property of 0 in the exponents. If I was to take 3, continually to follow my pattern, means I would divide by 3. So what is 3 divided by 3? Well, 3 divided by 3 is 1. And we discover that 0, or 3 to the 0 power, is equal to 1. What we would also discover is that anytime we use any of these numbers, if we did 3s or 2s or 4s or 5s or 10s, and we took them to the 0 power, what we would discover is every single time to the 0 power would equal the number 1. And so even take Mr. Gullett to the 0 power, I would equal 1. So anything to the 0 power equals 1. X to the 0 power is equal to 1. So now we go and we take that and we continue to follow our pattern. Because our pattern's worked so far, we divide by 3 again. Well, what I'll notice is that if I take 1 and divide it by 3, which lines up with 3 to the negative 1, what I'm going to discover is that 1 divided by 3 is really just the fraction 1/3. 1/3 is just another way to write a miniature division problem, right? 1 divided by 3 is the same as 1 over 3. As you can hopefully start to discover, there's a pattern coming again. I divide by 3. 1/3 divided by 3 is the same as saying, right? 1/3 divided by 3 is the same as saying 1/3 times 1/3, because we do the reciprocal. For those of you who remember dividing fractions from a while back, 1/3 times 1/3 is actually equal to 1/9. And so we are continuing our pattern, and we discover that the next one, or 3 to the negative 2, is equal to 1/9. And hopefully some of you are starting to discover without even having to think, 3 to the negative third power is 1 over 27. So what we discover is that a negative exponent does not create a negative number. A negative exponent just creates the reciprocal of its corresponding exponent. So 3 to the second is the same as 3 to the negative second, but it's a reciprocal. 3 to the third equals 27. So 3 to the negative third equals 1 over 27. 3 to the fourth equals 81. So hopefully you can guess what the next one's going to be. So 3 to the negative fourth is equal to 1 over 81. 3 to the fifth is equal to 243. So obviously 3 to the negative fifth is equal to 1 over 243. And so again, a reminder, a negative exponent does not make a negative number. A negative exponent just says it's reciprocal of what it would be if it was not negative. Hopefully that makes some sense for you. So that's our first thing. We talk about the property of 0, or the rule of 0. Anything to the 0 power is equal to 1. We also talk about negative exponents are not making the number negative. They just make it its reciprocal of what it would be if it was not negative. And so those are our first two exponent rules that we're going to talk about. We're going to talk about a couple more. Let me go ahead and erase this for us. Give us a clean slate. And in this one, what we want to do is we want to talk about multiplication, or a product rule, and a quotient rule, meaning division. And in a multiplication or product rule, this is its pattern. If I have a variable or a number represented by a variable to a certain exponent, which we don't know yet, and I multiply it by that same variable to another exponent, so I have x to the m times x to the n, what that's really saying is that that is the same as x to the m plus n. So the m and the n, the exponents, as long as the variable or the base number is the same, all I have to do is add the exponents when I'm multiplying those two together. Let's look at that in more practical terms with maybe some numbers. So let's say instead I had x to the fourth times x to the second, we'll say. That would be the same as x to the 4 plus the second. X to the fourth plus the second is the same as x to the sixth. So if we have x to the fourth times x to the second, I really end up with x to the sixth power. Hopefully that makes a little bit of sense to you. Let's try something a little bit more challenging, and it's going to follow the same pattern. Let's say I had 2x to the negative 3 times 3x to the fourth. Well, when I have these numbers, if you don't know what a number that stands right in front of a variable, we call that a coefficient. And if we have a coefficient of 2 and 3, they're numbers already. They're not variables, so we actually know what they are. And guess what? We just follow normal multiplication rules for coefficients. So this is really just 2 times 3, just like you normally would. But now we get to our x's, and that is x to the negative 3 plus 4. So my final answer then is 2 times 3, which is 6. And then I have x, that, what's negative 3 plus 4? Well, negative 3 plus 4 is 1. So I just end up with that as my answer. And if I want to anything to the first power, I can just leave it off if I would like, if that makes me feel better. So 2x to the negative 3 times 3x to the fourth is really equal to 6x. Hopefully that makes a little bit of sense to you. So what I have is what we call the product rule. And I will be sending home some practice for that. And so hopefully that'll help you to make sense of it. Anytime I have a number to an exponent and I have that same base to another exponent, it's just like adding the exponents together. Well, if adding the exponents together, or excuse me, multiplying the exponents means adding them together, I wonder if anybody knows what dividing the exponents might do. Well, when we divide variables with exponents, we actually are going to subtract them. So here is our rule. If I have x to the m over x to the n, and again, fractions just really a miniature division problem. So x to the m over x to the n is really x to the m divided by x to the n, which then gives me the simplified answer of x, because that's the same base. And then it's x to the m, the top one, minus the bottom one. And there's our example right there. Now, let's see that with some numbers on it and see if that helps us a little bit. What if I had something like x to the 10th over x to the 4th? If I have x to the 10th over x to the 4th, are my bases the same? Yeah, they are. So we can use that base. And then this just becomes my top number minus my bottom number. Or, simplified, what is 10 minus 4? It is 6. So x to the 10th over x to the 4th is the same as x to the 6th. Let's explain that a little bit, why that works. If I have x to the 10th, would you not agree that that's the same as x times 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 x? I think that's 10 of them. All over x times x times x times x. And if we understand fractions, right, and we also understand division, if I have an x divided by x, isn't that just equal to 1? And 1 times anything is anything. So those make a 1, those make a 1, those make a 1. 1 times 1 times 1 is still 1, right? Those make a 1. So 1 times 1 times 1 times 1 make a 1. And I'm left with nothing on the bottom, but on top I have 1, 2, 3, 4, 5, and 6 x's. Thus, I still have x to the 6th power left. Hopefully that makes a little bit of sense to you. Let's try a couple more before we finish up for today. Let's try something with some numbers added into it. Let's say we have, or should I say those numbers are called the coefficients. Let's say I have 6x to the 5th all over 3x to the, let's say, the 2nd. Again, our coefficients are numbers. We're going to handle this the same way we always do. 6 divided by 3. What is 6 divided by 3? Well, 6 divided by 3 is 2. Then I have x to the 5th over x to the 2nd, which is really x to the 5 minus 2, because it's a division problem. And thus I end up with 2. What is 5 minus 2? It is to the 3rd. And there's my final answer for this division problem. Let's try one more to challenge ourselves a little bit. Let's say that we have 12 to the x to the 4th over 4x to the negative 2. Integer rules are coming into play. So hopefully you're comfortable and confident in your solving of integer problems. But again, the coefficients, I go ahead and I do the normal division with those. 12 divided by 4 is 3. Then I have the same variable. And look what I have. I have a 4. This one gets a little bit more thinking through it. 4 minus a negative 2. Now, anytime I have minus a negative, does anybody know what that means? Exactly right. It means it's going to be a plus or a positive. So my final answer is I have 3x, and this becomes 4 minus negative, or 4 plus 2, which ends up being to the 6th power. So 3x to the 6th power is our final answer. I know it's got a little bit of a glare on that, but hopefully you can see that. Maybe I'll write it over here. It's a little bit better. 3x to the 6th power. So today we talked about anything to the 0 power is a 1, no matter what it is. We talked about negative exponents do not make a number negative. All they do is make it its reciprocal. For example, 4 to the negative 2 is really 1 over 16. Think about that one. See if I'm right on that. We talked about the product rule of exponents. Anytime I have common variables or common base numbers, the powers just get added when I'm multiplying them. And then we talked about the division or the quotient rule. And that is, anytime I have numbers with common bases, I actually am just going to subtract the exponents. So hopefully there's enough here. Please rewind and rewatch if you need to. This is what we covered on day 1 of pre-algebra, and hopefully that gets you to where you're comfortable and ready to talk about exponents multiplied by exponents, which we'll be starting on day 2 of the pre-algebra prep class. Thank you.